The paper of the day is NEO, a Learn Query Optimizer. So this paper presents NEO, short for Neural Optimizer. It's the first end-to-end learning optimizer that generates highly efficient query execution plans using deep neural networks. NEO iteratively improves its performance through a combination of reinforcement learning and a search strategy. On 4 database systems and 3 query datasets, NEO consistently outperforms or matches existing commercial query optimizers. Example Oracles and Microsofts, which have been tuned over decades. Paper evaluated NEO's performance using both synthetic and real-world datasets to answer the following questions. How does performance of NEO compare to commercial high-quality optimizers? How well does NEO generalizes to new queries? How much overhead does NEO training and execution incur? How do the different encoding strategies impact query latency? How do other parameters, for example, search time or loss function, impact the overall performance? And finally, how robust is NEO to estimation errors? There were 3 different benchmarks used. First is JOM, or the join order benchmark, with a set of queries over the Internet Movie Database consisting of complex predicates designed to test query optimizers. Second is TPC Edge, the standard TPC Edge benchmark using a scale factor of 10. And third is SCORP, a 2 terabyte dataset together with 8,000 unique queries from an internal dashboard application provided by a large corporation on the condition of anonymity. There are 4 key contributions of this paper. First, NEO, an end-to-end learning approach to query optimization, including join order, index, and physical operator selection. Second, papers show that after training with a sample query workload, NEO is able to generalize even to the queries it has not encountered before. Third is paper evaluate query encoding techniques and propose a new one which implicitly represents correlations within the database. And finally, papers show that after a short training period, NEO is able to achieve performance comparable to Oracle's and Microsoft's query optimizers on their own respective execution engines. Now let's talk PS score. Overall, this paper is a rough read due to maths and algorithms, so it gets 5 out of 10 on readability. With 14 pages long, it scores 7 out of 10 on length. It's a research prototype with decent description, so that makes it 6 out of 10. Its industry value and learning meter is questionable, so it gets 5 out of 10 on each. Overall, PS score is 6 out of 10.